In this video, we shall look at how to multiply a matrix with another matrix. Before we discuss matrix multiplication, let's first look at the following operation, taking the transpose of a matrix. If we have a matrix A, and we want to determine the transpose of this matrix A, the transpose of such a matrix A is obtained by interchanging rows and columns. As an example, let's assume matrix A is given by the following matrix: 2, 1, 4, minus 3, 0, 2. So this is a 2 by 3 matrix. 2 rows and 3 columns. Now let's look at the transpose of matrix A. That means we have to interchange the rows and the columns of matrix A. So that means the transpose of A becomes 2, 1, 4, and minus 3, 0, 2. So the first row of matrix A becomes the first column of its transpose. Likewise, the second row of matrix A becomes the second column of its transpose. So the order of the transpose matrix in this case is 3 by 2. Let's look at another example. Say we have matrix B given by 2, minus 4, minus 4, 3. The transpose of B is quite simply this will become the first column, so 2 minus 4, and this will become the second column, minus 4, 3. However, you see that it is identical to the original matrix B. So when a matrix equals to its transpose, we say such a matrix is a symmetric matrix. What about if we have the following matrix? Matrix C equals 0, minus 2, 2, 0. Its transpose would be 0, minus 2, 2, 0. By comparing these two, you see that the transpose of C is minus C. When the transpose of a matrix equals minus of that matrix, the matrix is known as skew-symmetric matrix. Now let's look at matrix multiplication. Assume we have two matrices. The first matrix A is given by 2, 1, 4, minus 3, 0, 2, and matrix B is given by 3, 5, 2, minus 1, 4, 2. Obviously, the order of matrix A and B are different. Can we do the multiplication of matrix A and matrix B? Well, to answer that question, we need to determine the order of A and the order of B. The order of matrix A is 2 by 3. There are 2 rows and 3 columns. The order of matrix B is 3 by 2. Now, if the number of columns of the first matrix is identical to the number of rows of the second matrix, then we can determine the product. We can multiply matrix A with B. The resulting product will have an order of 2 by 2. So the resulting matrix that we obtain by multiplying A and B together, with A being the first matrix and B being the second matrix, is a 2 by 2 matrix. One number here, one number here, one number here, and one number there. Let's determine this element. This element occupies the first row and the first column. So to determine that number, we have to take the first row of A and multiply that with the first column of B. So 2 times 3, that is 6, plus 1 times 2, so that is 2, plus 4 times 4, and that is 16, which is 24. So there we have it. The first element is 24. Now let's determine that element. That element occupies the first row and the second column. That means you take the first row of matrix A times the second column of matrix B. So 2 times 5, that is 10, plus 1 times minus 1, so that is minus 1, plus 4 times 2, and that's positive 8, which will give you 17. So that element is 17. What about this element? It occupies the second row and the first column. So that means we have to take row number 2 of matrix A and multiply that with column number 1 of matrix B. So that means 3 times 3, that's minus 9, plus 0 times 2, that is 0, plus 2 times 4, and that is 8, and gonna get minus 1. So there you go, we get minus 1. Now the last element that occupies the second row and the second column. So that can be determined by taking the second row of matrix A and multiplying that with the second column of matrix B. So minus 3 times 5, so that's minus 15. 0 times minus 1, so that is 0. 2 times 2, and that is 4. And that will give you minus 11, which is the answer for the last element, minus 11. As we have said earlier, this is a matrix with the order 2 by 2. Now let's take the following multiplication. B times A. They're the same two matrices, but now the multiplication is performed with an opposite order. Matrix B has an order of 3 by 2. Matrix A, the order is 2 by 3. So since the number of columns of the first matrix in the product is the same as the number of rows in the second matrix of that product, right there, we can multiply these two matrices as well in that order. And the resulting matrix will be a matrix of order 3 by 3. Since we know it's going to be a 3 by 3 matrix, so there must be 9 elements like that. And we need to determine each of these 9 elements. So let's determine that element. It occupies the first row and the first column. So that means the first row of the first matrix times the first column of the second matrix. And that's going to give you 3 times 2, that is 6, plus 5 times minus 3, that is minus 15, which is minus 9. So there we have it. The first element is minus 9. Now the second element, it occupies the first row and the second column. So the first row of the first matrix multiplies with the second column of the second matrix. 3 times 1, that is 3, plus 5 times 0, 0. So the answer is 3. Right there. Now that element occupying the first row and the third column. So that means first row of the first matrix times the third column of the second matrix. So 3 times 4, that is 12, plus 5 times 2, and that is 10. So that's going to give you 22. 22. So let's move on to the second row of the product. It occupies the second row and the first column. So second row and the first column. So when you multiply those, 2 times 2, that is 4, plus minus 1 times minus 3, that is 3. So the answer is 7. So that element right there is 7. Next, that element, it occupies the second row and the second column. So second row with the second column. So 2 times 1, 2, minus 1 times 0 is 0. So that means 2. That element, it occupies the second row and the third column. Second row and the third column. So 2 times 4, that's 8, minus 1 times 2, so that's minus 2, and that's going to give you 6 for it. 6. Let's move on to this. It occupies the third row and the first column. So third row and first column. 4 times 2, that is 8. 2 times minus 3, that is minus 6. So that's going to give you a 2. Now that element, third row and the second column. So that means the third row of the first matrix and the second column of the second matrix. 4 times 1, so that is 4. 2 times 0, that is 0. So the answer is 4. So finally, the last element, which occupies the third row and the third column. So that is the result of multiplying the third row of the first matrix and the third column of the second matrix. So 4 times 4, that is 16. 2 times 2, that is 4. And that's going to give you a 20. A 20 right there. So you have a 3 by 3 matrix for the product BA. As you can see, B times A is a 3 by 3 matrix with the following result. Compare that with AB, which is a 2 by 2 matrix, and with that result. That indicates generally in matrix multiplication, if you have two matrices A, B, you multiply them in that order, that is not necessarily the same as B times A. So in general, in matrix multiplication, the commutative law is not satisfied. Let's look at the following problem. You have matrix A defined by that, and B is given by that. So you see the order of A is 2 by 2, the order of B is also 2 by 2. So since the number of columns of the first matrix is the same as number of rows of the second matrix, we should be able to do the multiplication, and the resulting matrix, it will be the order of 2 by 2. So let's see how that works. AB. It will be a 2 by 2 matrix, so it will have 4 elements like that. So let's determine the first element. That can be obtained by multiplying the first row of A with the first column of B. So 2 times minus 1, so that's minus 2, plus minus 1 times 2, that's minus 2. That's going to give you a minus 4. Next, this element that can be obtained by multiplying the first row of the first matrix with the second column of the second matrix. So 2 times 1, that is 2, minus 1 times minus 4 is 4, so plus 4. You're going to get 6. Now this element that occupies row number 2 in the first column, so row number 2 of the first matrix and column of the second matrix. So 4 times minus 1, minus 4, 3 times 2, that is 6, so the answer is 2. And finally, this element, which occupies the second row and the second column of the product, is obtained by multiplying the second row of the first matrix with the second column of the second matrix. So 4 times 1, that is 4, 3 times minus 4, that's minus 12, and you get minus 8. Right there. So this is how matrix multiplications are generally done. Doesn't matter what the size of the matrices are. Here we will invite the viewers to work out the multiplication of these matrices in reverse. We'll give you the answer. It's going to be 2, 4, minus 12, minus 14. And as you can see, BA is not the same as AB as we have discussed previously. As always, thank you for watching.